So for those of you dealing with connected math, this is moving straight ahead. Investigation 4.3. It's a quick little summary here. So we have group 1 and group 2. And in group 1 you have y equals 3x, y equals 5 plus 3x, y equals 10 plus 3x, and y is equal to negative 5 plus 3x. And we're asked to graph it on a graphing calculator and then figure out what these things have in common. So let's take a look at this. If I were to graph these, I would get a graph that looked like this. See the equations, see the graph. Well, what do you notice about this graph, these lines? Well, it appears as though none of these lines, even if they were to go on forever, would never cross. Well, what do we call that? That means they are parallel lines. So the real question in this problem is what caused all three of these lines to be parallel? So let's take a look at our equations. What do you notice in all three of these equations? Well, they have different y-intercepts, right? I mean, we can see that in the graph. But their slopes are always the same. Their slope is always 3. So is it possible that equations with the same slope have parallel lines? Well, let's double check. Let's take a look at our part B, our group 2 rather. So we're going to take group 2 and we're going to graph it and see if we see a common relationship here. So I'm going to go ahead and graph it. And we get parallel lines again. This time the lines are all going down. And let's look at the equations. Well, x is being multiplied by the same value every time. In this case, x is being multiplied by negative 2 every time. So I think we have a rule. I think we have an algorithm. If we have equations of lines with the same slope, we know we have parallel lines. Excellent. That's easy enough to do. So we're also asked to come up with another group. Well, it doesn't matter what our slope is. We can make a bunch of parallel lines. So we could have y is equal to 3 over 2x. If I'm going to keep a slope of 3 over 2, a parallel line would be anything with a different y-intercept. So all three of these would have the same slope, so they would all be parallel lines. So let's take a look at question B. We have pair 1, pair 2, and pair 3. So let's take a look at the graph of pair 1. All right. So when I take a look, I end up with two lines that look like they have a perpendicular intersection, right? So let's see if that works for our other pairs. So pair 1 ended up with what looked like a perpendicular intersection. So just pair 2 is going to be 1/3 x and negative 3x. Let's see what happens when we graph it. Look, we get another perpendicular intersection. Well, let's try the third pair. I think we're coming close to another algorithm here. Let's look at the third pair. That's negative 1/4 x. And we graph it. All right. Every time we graph one of these pairs, we end up with perpendicular lines. So if we go back, let's take a look at what made them perpendicular. Well, in pair 1, we had a slope of 2 and negative 1/2. In pair 2, we have a slope of 3 and negative 1/4, because that's 1/4, right? For pair 3, we have a slope of negative 3 and positive 1/3. Well, what do you notice between 2 and 1/2, 4 and 1/4, and 3 and 1/3? They're all reciprocals, aren't they? What else do you notice? One's positive and one's negative. Positive, negative, negative, positive. I think we've found an algorithm. So if we have two lines that have opposite reciprocal slopes, we get perpendicular lines. Opposite meaning one's positive and one's negative. Reciprocal meaning you're taking the reciprocal of it. And then we end up with perpendicular lines. All right, so we have our algorithm. For question 3, write an equation of 4 lines that intersect to form a parallelogram. Well, if we have a parallelogram, we know that we have 4 lines, or 2 pairs of parallel lines. So let's just write 2 parallel lines. Y equals negative 3x plus 5. Y equals negative 3 for x plus, let's say, minus 5. All right. And then let's try some opposite reciprocals. I'm going to switch to my graphing calculator here and see if I can make it work. If I just have 2 lines that are parallel, 2 pairs of parallel lines. So here we go. So I said, I forgot what I said. Negative 3. So let's try negative 3x plus 5, negative 3x minus 5. Let's have another pair of parallel lines. Let's try positive, let's say positive 2x and 2x minus 7. I can pick anything. Let's see what we get. Oh look, I get a parallelogram right here, don't I? Excellent. For my triangle, a right triangle, I need 3 equations. I'm going to get rid of the yellow line. You can't really see it too well anyways. So we need 1 pair of lines that are perpendicular. So if I keep this negative 3x to the plus 5, my opposite reciprocal is going to be positive, and it's going to be 1/3 x. We can keep the minus 5, doesn't really matter. And then my last line doesn't really matter what it is. So let's see what I get. All right, and here's my right angle right here. Perfect. So it could be any pair of perpendicular lines, and then any third equation will work just fine. Excellent. I think we have it.